For centuries, we've been absolutely obsessed with this idea of human perfection. So today, we're going to trace that obsession from its really dark beginnings, ranking human worth, all the way to the high-tech reality of actually designing it. We'll explore how we got here and where we might be headed.
And really, it all comes down to this one huge question. Is this quest for perfection a noble goal? Something to end suffering and unlock our true potential? Or is it a very slippery slope back to some of history's most dangerous ideas? The stakes, well, they couldn't be higher.
Look, this conversation, it's not new. Not by a long shot. This timeline shows that the impulse to engineer humanity goes back centuries. It started with simple classification back in the 1700s, then it got a name, eugenics, in the 1880s. It actually became law in the 20th century, and then in 2018, it took a radical leap into a new phase with the birth of the first gene-edited babies.
Okay, so here's the game plan for today. We're going to start with the historical framework that was used to justify prejudice. Then we'll see how the very metric of human value shifted from, believe it or not, bones to DNA. We'll look at the incredible tools we have right now, confront some heavy ethical echoes from the past, and finally explore the two profound choices we now face for the future of our species. All right, first step, we have to get our heads around how this all began. And this wasn't just random bias, no. It was a systematic effort to use the authority of science to build an intellectual justification for social hierarchies and prejudice.
And right at the heart of this whole thing is one word: eugenics. Francis Galton coined it back in 1883. It literally means well-born. The idea was brutally simple. Hey, if we can breed better horses and dogs, why can't we breed better people? This core logic right here fueled a global movement.
What's really wild is just how early this impulse to rank people started. Back in the 1700s, Carl Linnaeus, the father of taxonomy, wasn't just classifying humans by where they lived, he was assigning them totally subjective, biased personality traits and claiming they were governed by different principles. Science was being twisted not just to describe, but to create a hierarchy.
So these ideas didn't just stay in the ether. They got formalized by a few key thinkers. You had Herbert Spencer, who twisted Darwin's theories to argue that helping the poor was actually a mistake holding back evolution. Then Francis Galton, who we just mentioned, wanted to literally breed humans for talent. And this guy, Cesare Lombroso, claimed he could spot a born criminal just by the shape of their jaw. In their world, your worth wasn't your character. It was literally written in your bones and your bloodline.
And believe me, this wasn't just some abstract theory debated in universities. This chilling quote, it comes from a 1927 U.S. Supreme Court decision that legalized forced sterilization. It's proof of how these pseudo-scientific ideas got baked into the highest levels of power and had devastating, real-world consequences for tens of thousands of people.
Okay, so after World War II, the absolute horrors of the Holocaust made the word eugenics radioactive, politically toxic. But the core idea, it didn't just vanish, it just morphed, re-emerging in a new, much more sophisticated disguise. The focus shifted from measuring skulls to reading the code of life itself, DNA. And this is where you see the huge pivot. The old, totally debunked metric was something called craniometry, measuring skulls to prove intelligence. The new metric is the genetic code. Now, DNA isn't just seen as a biological molecule anymore. It's viewed as a digital information system, like a biological hard drive that can be read, stored, and, most importantly, edited. To really wrap your head around the power of this new way of thinking, get this. The information density of DNA is mind-boggling. Just 4 grams, about the weight of a teaspoon of sugar, could theoretically store all the digital data the entire world produces in a single year. When you hear that, you start to see why DNA is now seen as the ultimate blueprint, not just for life, but for information itself. So this big shift, this move from seeing life as just biology to seeing it as information, well, it's handed us a brand new set of tools. Let's take a look at the actual technologies that have turned that old eugenic dream of selection into a modern clinical reality. So the main tool in the box here is something called pre-implantation genetic testing, or PGT. For couples using IVF, it's a multi-step process. First, embryos are created in a lab. Then, a few cells are carefully biopsied from each one and sent off for genetic analysis. The results come back, they're reviewed, and then parents can choose which embryo they want to transfer for implantation. And it's not just one test, it's more like a whole menu of options. PGTA looks for major chromosomal errors. PGTM can target specific single-gene diseases like cystic fibrosis. But the most futuristic and, let's be honest, the most controversial is PGTP. This uses something called polygenic risk scores to basically rank embryos based on their statistical odds for developing complex traits, everything from heart disease risk to, yes, even things like height or potential IQ.
But, just selecting embryos, that's only half the story. The other massive tool is CRISPR-Cas9. Think of it like a find and replace function for DNA. And this is not science fiction. Back in 2018, it was used to create Lulu and Nana, the first babies whose genes were intentionally and permanently altered, a change that could be passed down through their family line forever.
Okay, so we've got these unbelievably powerful new tools, but they bring up some very old and, frankly, very uncomfortable questions. This is where the past and the present really collide, and it forces us to ask, are we just repeating history, but with fancier tech? Let's just put the goals side by side, then and now. The old-school eugenicists, they wanted to breed for these fuzzy concepts like talent and character. What about today? Well, we can select embryos based on a data-driven scorecard for disease risk and potentially for the very same kinds of traits. The language has shifted from purification to optimization, but that underlying urge to select for better, it feels strikingly similar. And this, right here, is the heart of the ethical debate raging today. Experts are worried about creating a genetic divide between the designed and the natural. There's a huge concern that these technologies are so expensive, they'll only be for the wealthy, making social inequality way worse. We also might be accidentally filtering out genetic diversity that could be really important down the line. And think about the pressure on a kid who is literally designed to be the smart one. When you boil it all down, this whole conversation leads us to a massive fork in the road, a fundamental choice about what it even means to be human. The source material frames this as a decision between two very different paths for our evolution.
So, on one path, you've got what we can call the manufactured path. This is where we basically outsource our own evolution to labs and AI. The human body is seen as a piece of hardware, a product that can be debugged and upgraded. On the other path is the sovereign path. This view says that our consciousness, our intention, our inner state, that these can be the real drivers of our biology. That the body isn't a machine, it's a sacred vessel.
This table really lays out just how deep that philosophical divide is. Is life a sacred creation, or is it a manufactured product? Is our DNA a sacred blueprint, or is it just programmable code? Is death a natural spiritual transition, or is it just a technical glitch that science needs to fix? Is immortality found in the spirit, or is it something you achieve by uploading your data to the cloud? These are the two competing worldviews on the table.
And that gets us to the absolute core of it, the real conflict here. It's all about ownership. Think about it. When a corporation or a lab can edit, patent, and own the rights to a specific genetic sequence inside a human being, that person risks becoming less of a sovereign individual and more of a proprietary product. So that leaves us with this final, massive question to chew on. Is our future something that's going to be written, debugged, and patented in a laboratory? Or is our true potential, our health, and our evolution something that has to be realized from within? That's the choice we have to make.